it is possible that the T-12 bulbs caused the original ballast to fail after 2 years. T-12 bulbs are not designed to work with electronic ballasts, and using them can cause the ballast to overheat and fail. There are known breaker and ballast compatibility issues that one should be aware of. Some AFCIs are not compatible with certain types of electronic ballasts. This can cause the AFCI to trip when the light is turned on. The best way to avoid AFCI and ballast compatibility issues is to use AFCIs that are specifically designed for use with electronic ballasts. A list of compatible AFCIs can be found on the website of the National Electrical Manufacturers Association, also known as NEMA. Here are some tips for troubleshooting AFCI and ballast compatibility issues. Firstly, make sure that the AFCI is compatible with the type of ballast that is being used. Secondly, make sure that the wiring is correct. Thirdly, make sure that the connections are tight. And fourthly, make sure that the bulbs are properly seated. If problems continue, contact the manufacturer of the AFCI or the ballast for assistance. Arc fault circuit interrupters, or AFCIs, are designed to protect against electrical fires caused by arcing faults. These faults can occur when damaged or deteriorated wiring creates an unintended path for electrical current. When this happens, it can generate heat, sparks, and potentially ignite nearby materials, leading to a fire. AFCIs are designed to detect these dangerous arcing conditions and quickly shut off the power to the circuit, thus preventing a fire. There are two main types of AFCIs. Firstly, branch or feeder AFCIs, and secondly, combination AFCIs. Branch or feeder AFCIs protect against arcing faults in the branch circuit wiring, while combination AFCIs provide broader protection by detecting both branch circuit arcing faults and series arcing faults within cord-connected appliances and extension cords. Combination AFCIs are now the most commonly required type in residential installations due to their comprehensive protection. Electronic ballasts are commonly used in fluorescent and LED lighting systems to regulate the voltage and current supplied to the lamps. They are more energy efficient and provide better performance compared to older magnetic ballasts. However, electronic ballasts can sometimes generate electrical noise or harmonics that can interfere with the operation of AFCIs. This interference can cause the AFCI to trip even when there is no actual arcing fault present. This is where compatibility issues can arise. Some AFCIs are more susceptible to nuisance tripping caused by electronic ballast than others. This is due to differences in their design and sensitivity to high-frequency electrical noise. To mitigate these issues, it is important to choose AFCIs that are specifically designed to work with electronic ballasts and are less prone to nuisance tripping. Several factors can contribute to AFCI and ballast compatibility issues. Firstly, the type of ballast used. Different types of electronic ballasts produce varying levels of electrical noise. Some ballasts are designed with built-in filters to reduce noise, while others may not have this feature. Secondly, the quality of wiring and connections. Poor wiring or loose connections can exacerbate electrical noise and increase the likelihood of AFCI tripping. Proper wiring practices, including tight connections and the use of high-quality conductors, are essential for minimizing these issues. Thirdly, the distance between the ballast and the AFCI. The closer the ballast is to the AFCI, the greater the potential for interference. In some cases, separating the ballast and AFCI by a greater distance can help reduce nuisance tripping. Fourthly, the sensitivity of the AFCI. Some AFCIs are more sensitive to electrical noise than others. Using an AFCI with a lower sensitivity setting may help reduce nuisance tripping, but it is important to ensure that the AFCI still provides adequate protection against actual arcing faults. There are several steps to take to troubleshoot AFCI and ballast compatibility issues. Firstly, verify compatibility. Check the manufacturer's specifications for both the AFCI and the ballast to ensure that they are compatible. Some manufacturers provide lists of compatible devices or specific recommendations for avoiding compatibility issues. Secondly, inspect wiring and connections. Carefully inspect all wiring and connections in the circuit to ensure that they are properly installed and tightened. Look for any signs of damage or deterioration and replace any faulty components. Thirdly, test with different ballasts. If possible, try using a different type or brand of electronic ballast to see if it resolves the tripping issue. Choose a ballast that is known to be compatible with AFCIs and has built-in noise filters. Fourthly, relocate the AFCI or ballast. Moving the AFCI or ballast to a different location in the circuit can sometimes reduce interference and prevent nuisance tripping. Experiment with different locations to find the optimal configuration. Fifthly, use a line filter. Installing a line filter on the circuit can help reduce electrical noise and prevent it from interfering with the AFCI. Choose a filter that is specifically designed for use with electronic ballasts. Sixthly, consult with an electrician. If problems persist despite troubleshooting efforts, consult with a qualified electrician who has experience with AFCI and ballast compatibility issues. They can perform additional testing and provide expert recommendations for resolving the problem. The National Electrical Code, or NEC, provides guidelines for the installation and use of AFCIs. It specifies the locations where AFCIs are required and provides recommendations for minimizing nuisance tripping. Some relevant NEC sections include 210.12, which covers arc fault circuit interrupter protection, and it requires AFCIs in dwelling units in various locations. Also, 410.73, which addresses ballasts, and it includes requirements for the proper installation and use of ballast in lighting fixtures. AFCI technology continues to evolve, and manufacturers are constantly developing new and improved AFCIs that are less prone to nuisance tripping. These advancements include improved filtering techniques, more sophisticated algorithms for detecting arcing faults, and better compatibility with electronic ballasts. Staying informed about the latest AFCI technology and best practices can help electricians and homeowners avoid compatibility issues and ensure the safe and reliable operation of electrical systems. There are several resources available for learning more about AFCI and ballast compatibility. Firstly, the National Electrical Manufacturers Association, also known as NEMA, provides information and resources on electrical products, including AFCIs and ballasts. Their website includes technical documents, application guides, and lists of compatible devices. Secondly, electrical trade publications such as Electrical Construction and Maintenance, or EC&M, and Electrical Contractor magazine offer articles and insights on AFCI technology and troubleshooting. Thirdly, electrical training programs and continuing education courses provide in-depth instruction on AFCIs, wiring practices, and electrical safety. These courses can help electricians stay up to date on the latest code requirements and best practices. Fourthly, online forums and discussion groups can be a valuable resource for sharing experiences and seeking advice from other electricians and industry professionals. These forums can provide practical tips and solutions for troubleshooting AFCI and ballast compatibility issues. Some AFCIs are designed with features that help reduce nuisance tripping. Firstly, advanced filtering. These AFCIs incorporate advanced filtering techniques to reduce the impact of electrical noise generated by electronic ballasts and other devices. The filters are designed to block high-frequency noise while allowing normal electrical current to pass through. Secondly, waveform analysis. These AFCIs use sophisticated waveform analysis algorithms to distinguish between actual arcing faults and nuisance tripping caused by electrical noise. The algorithms analyze the shape and characteristics of the electrical waveform to identify patterns that are indicative of an arcing fault. Thirdly, adjustable sensitivity. Some AFCIs allow the user to adjust the sensitivity setting to reduce nuisance tripping. Lowering the sensitivity can make the AFCI less prone to tripping due to electrical noise, but it is important to ensure that the AFCI still provides adequate protection against actual arcing faults. Fourthly, diagnostic indicators. These AFCIs include diagnostic indicators that can help identify the cause of a tripping event. The indicators may provide information on the type of fault that occurred, such as an arc fault, ground fault, or overcurrent. This information can be helpful in troubleshooting the problem and determining the appropriate course of action. When replacing a ballast, it is important to choose a replacement that is compatible with the existing lighting fixture and the type of bulbs being used. Consider the following factors. Firstly, ballast type. Determine whether the original ballast was magnetic or electronic. If it was electronic, choose a replacement that is also electronic and has similar specifications. Secondly, voltage and wattage. Ensure that the replacement ballast has the same voltage and wattage ratings as the original. Using a ballast with incorrect ratings can damage the fixture or the bulbs. Thirdly, bulb type. Choose a ballast that is designed for use with the specific type of bulbs being used, such as T-8 or T-12. Using a ballast with the wrong bulb type can cause the bulbs to fail prematurely or not function properly. Fourthly, energy efficiency. Consider choosing a ballast that is energy efficient to reduce energy consumption and lower electricity bills. Look for ballasts that are Energy SAR certified. Fifthly, safety certifications. Ensure that the replacement ballast is certified by a recognized safety organization such as UL or ETL. This certification indicates that the ballast has been tested and meets safety standards. When wiring a lighting fixture with an electronic ballast, it is important to follow proper wiring practices to ensure safe and reliable operation. Consider the following tips. Firstly, use the correct wire size. Use the wire size specified by the manufacturer for the lighting fixture and the ballast. Using a wire that is too small can cause overheating and potentially lead to a fire. Secondly, make tight connections. Ensure that all wire connections are tight and secure. Loose connections can cause arcing and overheating, which can damage the fixture or the ballast. Thirdly, follow the wiring diagram. Follow the wiring diagram provided by the manufacturer when connecting the ballast to the lighting fixture. Incorrect wiring can cause the fixture to malfunction or create a safety hazard. Fourthly, ground the fixture. Ground the lighting fixture properly to protect against electrical shock. Connect the grounding wire to the grounding terminal in the fixture and to a grounded electrical box. Fifthly, protect the wires. Protect the wires from damage by using conduit or cable clamps. This will prevent the wires from being pinched or cut, which can cause a short circuit or other electrical problems. Lighting control systems can sometimes contribute to side tripping issues. Firstly, dimmer switches. Some dimmer switches are not compatible with electronic ballasts and can cause them to generate excessive electrical noise, leading to side tripping. Use dimmer switches that are specifically designed for use with electronic ballasts. Secondly, occupancy sensors. Occupancy sensors can sometimes cause a sized trip when they rapidly switch the light on and off. This is because the sudden surge of current can create a transient voltage that triggers the AFCI. Use occupancy sensors that have a soft switching feature to reduce the surge of current. Thirdly, timers. Timers can also cause a sized trip if they switch the lights on and off too frequently. Use timers that have a delay function to prevent rapid switching. Fourthly, lighting control panels. Lighting control panels can sometimes introduce electrical noise into the circuit, leading to side tripping. Ensure that the lighting control panel is properly grounded and shielded to minimize noise. When working with electrical systems, it is important to follow safety precautions to prevent electrical shock and other hazards. Firstly, turn off the power. Always turn off the power to the circuit before working on any electrical components. Use a voltage tester to verify that the power is off. Secondly, wear safety gear. Wear safety glasses and insulated gloves when working with electrical systems. This will protect your eyes and hands from electrical shock and other hazards. Thirdly, use insulated tools. Use insulated tools when working with electrical systems. This will prevent electrical current from flowing through your body if you accidentally touch a live wire. Fourthly, follow the code. Follow the National Electrical Code, or NEC, and other applicable codes and standards when installing and maintaining electrical systems. This will ensure that the systems are safe and reliable. Fifthly, get help if needed. If you are not comfortable working with electrical systems, get help from a qualified electrician. Working with electricity can be dangerous, and it is important to have the necessary knowledge and skills to do the job safely. In summary, AFCI and ballast compatibility issues can be frustrating to troubleshoot, but understanding the underlying causes and following proper troubleshooting steps can help resolve these problems. By choosing compatible components, following proper wiring practices, and staying informed about the latest technology, electricians and homeowners can ensure the safe and reliable operation of lighting systems.